Electrical load calculation for a base building with future build-outs requires careful consideration of both known and estimated loads. Let's begin with the known loads. Firstly, there are 12 air conditioning units, each drawing a maximum of 30 amps. This results in a total air conditioning load of 360 amps. Secondly, there are 12 electric water heaters, each rated at 15 amps, leading to a total water heater load of 180 amps. Thirdly, the building incorporates 12 small furnaces. Assuming each furnace draws approximately 10 amps, the total furnace load is 120 amps. Fourthly, for safety and compliance, there are 12 exit lights, each consuming about 3 amps, totaling 36 amps. Fifthly, the building includes 24 emergency lights, with each light drawing 1 amp, resulting in a total emergency lighting load of 24 amps. Sixthly, there are 40 outside soffit lights, each using a 60-watt bulb. At 120 volts, this equates to 0.5 amps per bulb for a total soffit lighting load of 20 amps. Now, let's address the unknown loads, specifically the general lighting and receptacle loads for future build-outs. Since the exact layout and usage of these spaces are not yet defined, we need to estimate these loads based on standard practices for professional office spaces, which will house doctors, lawyers, and general office use. A common estimation for professional office spaces is a lighting and receptacle load of 3 volt-amps per square foot. Given the building's total area of 18,850 square feet, the estimated total volt-amps for lighting and receptacles is 56,550 volt-amps. To convert volt-amps to watts, we need to consider the power factor. For typical office equipment, a power factor of 0.85 is often assumed. Therefore, the estimated wattage for lighting and receptacles is calculated by dividing the total volt-amps by the power factor, resulting in approximately 66,530 watts. Next, we need to sum all the known and estimated loads to determine the total connected load. The air conditioning units account for 360 amps, the water heaters for 180 amps, the furnaces for 120 amps, the exit lights for 36 amps, the emergency lights for 24 amps, and the soffit lights for 20 amps. The estimated general lighting and receptacle load of 66,530 watts must be converted to amps. Dividing 66,530 watts by the voltage of 240 volts, we get approximately 277.2 amps. Adding all these loads together, the total connected load for the building is approximately 997.2 amps. Now let's discuss service considerations. Given that three-phase power is not available, a single-phase service will be required. To determine the appropriate service rating, we need to apply a demand factor to the total connected load, according to the National Electrical Code, also known as NEC. A demand factor accounts for the fact that not all loads will be operating at their maximum capacity simultaneously. For commercial buildings, a demand factor of 0.75 is typically used. Applying this demand factor to the total connected load of 997.2 amps, the service rating is calculated as 997.2 amps multiplied by 0.75, which equals approximately 748 amps. Therefore, based on these calculations, it is recommended that you request a 750 amp, 120/240 volt single-phase service from the utility company. This capacity should be sufficient for the base building and future build-outs, assuming that the estimated general lighting and receptacle loads are reasonably accurate. However, it is important to note that as build-outs occur and the actual electrical usage becomes clearer, the electrical system should be reevaluated to ensure that the service capacity remains adequate. It is also advisable to consult with a qualified electrician or electrical engineer to verify these calculations and ensure compliance with all applicable codes and regulations. This detailed load calculation provides a solid foundation for designing a safe and reliable electrical system for the building. It's critical to follow a systematic approach. Firstly, identify all known loads including air conditioning units, water heaters, furnaces, and lighting. Secondly, Estimate unknown loads such as general lighting and receptacles based on the building's intended use. Thirdly, calculate the total connected load by summing all known and estimated loads, converting watts to amps as necessary. Fourthly, apply an appropriate demand factor to account for non-simultaneous operation of loads. Fifthly, determine the required service rating based on the demand-adjusted total load. Finally, consult with qualified professionals to validate the calculations and ensure compliance with applicable codes and regulations. Regarding the NEC reference, it's essential to consult the specific sections related to load calculations and demand factors for commercial buildings. These sections provide detailed guidance on determining appropriate demand factors for various types of loads, such as lighting, receptacles, heating, and air conditioning. Additionally, it's important to consider any specific requirements or recommendations from the local utility company. They may have their own guidelines or standards for service sizing and connection requirements. It is important to know the different load types. There are mainly two types of loads. Firstly, continuous loads, which are loads that operate for 3 hours or more continuously. And secondly, non-continuous loads, which are loads that operate for less than 3 hours continuously. Continuous loads are typically multiplied by a factor of 1.25 to account for the sustained nature of their operation. In this case, the air conditioning units and water heaters may be considered continuous loads depending on their operating cycles. Therefore, it may be necessary to adjust their calculated loads accordingly. It is also important to consider the voltage drop in the electrical system. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. It is recommended to perform voltage drop calculations to ensure that the electrical system is properly sized to minimize voltage drop. Considering future expansion is also important. While the current load calculation provides a reasonable estimate for the base building and initial build-outs, it is important to anticipate future expansion and potential increases in electrical demand. It may be prudent to oversize the service capacity slightly to accommodate future growth. This can help avoid costly upgrades later on. Furthermore, it is important to install adequate raceways and conduit to facilitate future wiring changes and additions. Using energy-efficient lighting and equipment can significantly reduce the overall electrical load. Consider using LED lighting, which consumes significantly less energy than traditional incandescent or fluorescent lighting. Also, select energy-efficient appliances and equipment that meet or exceed industry standards. Energy-efficient measures can not only reduce the electrical load but also lower operating costs and improve the building's sustainability. Regularly inspect and maintain the electrical system. Periodic inspections can help identify potential problems such as loose connections, damaged wiring, or overloaded circuits. Regular maintenance, such as tightening connections and replacing worn components, can help prevent failures and ensure the safe and reliable operation of the electrical system. Keep detailed records of all electrical work performed, including load calculations, circuit diagrams, and equipment specifications. These records can be invaluable for future troubleshooting, maintenance, and expansion planning. Having accurate and up-to-date documentation can save time and money in the long run. Finally, it is essential to prioritize safety in all aspects of electrical work. Always follow safe work practices, wear appropriate personal protective equipment, and energize circuits before working on them. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electrical work can be dangerous, and it is not worth risking your safety. In summary, accurately calculating the electrical load for a base building with future build-outs is crucial for ensuring a safe and reliable electrical system. By carefully considering both known and estimated loads, applying appropriate demand factors, and consulting with qualified professionals, you can design an electrical system that meets the building's current and future needs. Adhering to the NEC and prioritizing safety are essential for all electrical work. Remember to regularly inspect and maintain the electrical system and keep detailed records of all work performed.